thank you very much for joining us. Dear participants, a very warm welcome to you, everybody. I'm very happy to have so many participants today here at our first railway talk. I'll make a short introduction only, and then we will start very soon. So I'd like to inform you, last year, UEEIV elected a new board, and the new board saw a high demand of activities for members and the members' associations of the union. So especially European-wide networking and know-how transfer was coming to our focus. Our three-column motto is CSC, Share, Connect, and Certify. And the certification for railway engineers and operators of track maintenance machines are still a highlight of the union, and we will upgrade and extend the system. But now we are talking about another motto. The other motto is part of the meeting today. The new railway talks are one of our services regarding connecting people and sharing knowledge. But I'll not talk so much now. I only like to say, please join the UEEIV via your national association. And if your national association is not member now, please inform us and bring us in contact with them. So I'd like to hand over now to my president colleague, Bernhard Knoll, and he will give you some more information, and then we will start with the presentations. Bernhard, please go ahead. Thank you very much.
Thank you, Olaf. So good evening, railway engineers. Good evening, ladies and gentlemen. On behalf of the Union of European Railway Engineer Association, I would like to welcome you to our first railway talk focused on critical factors success for hypercomplex railway projects. My name is Bernhard Knoll. I'm Vice President of the Union, and I'm your moderator for this event today. What do major projects, major public projects such as Stuttgart 21, the Berlin Airport, or Sydney Light Rail have in common? They could not be built in the scheduled time, and the construction cost exploded. So the reason for this was manifold. The complexity of this project certainly a main reason. Statistics show that today 1/3 of all projects fail and 2/3 do not achieve all their goals. So our today's railway talk want to give answers to the following questions. Why are railway projects hypercomplex? What are the main risks? What are the main requirements for being successful? Or how about the operator's perspective? And what about the life cycle cost approach? Today we try to give answers to all these questions, and we have managed to find two extraordinary experts who have experience in dealing with large projects, and they will share it with us at this seminar today. Before I will introduce them, some additional organizational notes. I think you have already mentioned that I will kindly ask you to switch off your microphone if you do not speak. I think this has been done in the background anyway. In order not to overstrain the internet capacity, I also would like you to switch off your cameras if you do not talk. We will record this event for all participants of this seminar, as well as for all members of the union, so that colleagues who are prevented from attending today will have the opportunity to review the seminar probably later, at a later date. If you do not agree with this procedure, please report it to us in advance. If you have any questions to the speaker during the speech, you are invited to formulate questions in our chat. So we have in this MS Teams the possibility to ask questions in the chat. I will try to summarize these questions and put it forward to the speakers immediately after the end of the presentation. Finally, I will ask you for additional questions you may have to the speaker and give all participants of this seminar the opportunity to ask his or her question directly to the presenter. Therefore, please open your microphone again and turn on your camera. We will try to handle it that you have the possibility to get in contact with our presentators. If you want to give any comment or feedback to this seminar, please leave a message in the chat or send us an email afterwards. So I think enough talking. I think now it is time to introduce to you the first speaker of today's seminar. It's a great pleasure for me to introduce to you Mr. Daniel Wirth, the Secretary of the Union and Senior System Engineer at various big projects like Gotthard or Alcatel and Thales Rail Signaling Solutions for Switzerland. He has studied at the ETH in Zurich and worked for Oerlikon and Swiss Railways SBB until 2006. So, please, Daniel, I give you the floor and tell us about your big experience for the last years.
Thank you, Bernhard. Good evening, ladies and gentlemen. As you heard, my name is Daniel Wirth. I'm a systems engineer and the secretary of the union. I was active 11 years for the railway technology in the Gotthard base tunnel. Now, why are railway projects hyper complex? This is the base technical system. It looks not very hyper complex. For what you have to think on it is that also electromechanicals are necessary. For every underground and every station project, you need electromechanics like automatic doors, air conditioning, fire detection, and ventilation systems for the emergency case. Then extend the railway system. The base for a railway project is an operating concept. This causes a corresponding topology. Not to forget that we also need civil work, and there noise and vibration is today a theme. Then without interface to existing lines, there has no sense to build a new line. And there, incident handling and evacuation is also to look on. And now, to build such a big project, you need temporary installations. You have to plan the authorization. You have to look on the environment aspects and also social aspects, naturally project management and cost. Not only project cost, look also on the operating cost. More our life cycle cost you will hear in the next presentation from Nino. An example, GBT was called for bidding as a functional requirement proposal with 4,800 main requirements. And every main requirement can have sub-requirements. We see up to 400 sub-requirements. So you see, and we have tested all these requirements at the end of the project. So you see, that's complex, hyper complex. And you will have to coordinate all these focuses one with others. Now, please, Charlotte, start the video.
For the 57-kilometer-long construction site inside the Gotthard Massif, the railway installations contractor takes over the various sections from the tunnel construction contractors in sequence. Work starts in the south, with the pilot section between Bodio and Faido. First of all, the temporary construction site systems are installed. The cables for the construction site power supply are laid. For telephone communications on the construction site, a landline is installed, and for radio communications, the antenna cable. Then the cooling system is installed. Every 250 meters, a cooling system can be connected to the water circuit. At the same time, the personnel location system is installed. Sensors in the tunnel monitor all movements of personnel. Installation of the temporary construction site systems is now complete. Installation of the railway infrastructure can begin. First, the medium voltage cables are laid. In the opposite bench, the optical fiber cables are pulled in. At the same time, the handrail with its integrated earthing conductor is mounted. The safety concept also includes independent emergency lighting. The railway track is now laid. Laying takes place in approximately 2,000-meter-long sections. On the first day, the 120 long rails are laid. The rails are put into the tunnel on rollers in pairs. They are then laid on track gauges and welded to the rails that are already in place. While the welds cool, the next pair of rails is pulled in. The rails are transported on the temporary track that was created in the laying process. In one day, 18 pairs of rails with a total length of 2,160 meters are laid. When all the rails of a section have been laid, the sleepers are delivered. The 7,200 sleepers for a single section are delivered by train. They are raised by a crane that runs on the train and then lowered onto the floor of the tunnel through the so-called bottomless wagon. When all of the sleepers have been laid, the rails are raised. The sleepers are mounted on the rails. The completed rail lattice is raised and fixed at the sides. The track is then straightened. The track is now perfectly positioned. Concreting can begin. The concrete for the track is mixed in the tunnel. The concrete train brings the individual components for 2 shifts to the construction site. At the construction site, the railway wagons deliver the components via conveyor belts and pipelines to the concrete mixer. The concrete pump supplies batches of 5 cubic meters of concrete to the concrete transporter. To protect the straightened rails, the transporter travels on the benches. It feeds the concrete to the distributor. The continuous supply of fresh concrete to the distributor allows 15 hours of uninterrupted concreting in 2 shifts. An average of 200 meters of ballastless track are completed per day. When the track is complete, the overhead conductor is installed. The conductor wire and suspension cable are unrolled from the moving train and brought into position in a single work step. The installation technicians then fasten the suspension cable to the supports that are already mounted in the tunnel. A total of more than 110 kilometers of overhead conductor and railway track are being installed in the Gotthard base tunnel. The installations for the 50 Hz, telecommunications, and safety systems are delivered fully assembled and tested in cabinets. The individual control elements are delivered as box-in-the-box modules. This prevents the sensitive electronics from coming into contact with the dusty air. In total, more than 2,400 cabinets are connected with optical fiber cables. When the Gotthard base tunnel is fully operational, trains will regularly travel through the tunnel at up to 250 kilometers an hour.
So I will continue. One remark to the personal location system. During the construction phase, this was mandatory because we are in a tunnel and the firefighters had exactly to know how many persons they had to evacuate from there in case of an emergency like fire. So now, next risk success factor. A complex system had to be planned and realized as well-balanced, all-including solutions. With a collection of not to the superior goals optimized subsystems, you will never reach an optimal solution. This is a picture. You have all subsystems, but the interfaces are not optimized to the all system solution. This should show like this. And to reach this, you need interface and integration management from the beginning on. Interface engineering is a kind of integration planning and design. In a major construction project, you need well-experienced engineers to coordinate the trades with all other trades. One possibility for the interface management is make a two-dimensional matrix with all trades and subsystems, like the example below. And for every intersection between two sides, make an interface document. This interface document is the collaboration contract between the two partners, and in minimum it should contain timeline, responsibility, technical requirements, localized requirements, and to be signed from the partners. And if the facts are changing, this contract has to be actualized, even if there is no interface between two possible partners. This has to be documented and signed from both sides. This is the header from our interface documents in Gotthard base tunnel. And the crossed field are the not existing detected interfaces. In Gotthard base tunnel, we had two simulation laboratory, one for the tunnel SCADA system. The tunnel has more than 70,000 data points, and one for the railway, the signaling data system. So, requirement to the project. One other success factor is the language. If two different trades are speaking English, then it can be that a word has the same word has different semantics, and this gives misunderstanding. So you need an interpreter to prevent misunderstanding. And you need system engineer in every subsystem who are specialists in this subsystem, but can also discuss interdisciplinary with all the trades. And as a general project manager, you need a systems engineer who has the overview, over the whole project. In smaller projects, this can also be the interpreter. This is a picture. Here, example traction current. He is expert with a deep know-how in traction current, but he has enough know-how in all the other trades so that he can optimize the interfaces with the other trades. Then you get this result, and you can make a good project. Then other possible success factor is the extended quality method RAMS, documented in the norm 50126. RAMS stand for reliability, availability, maintainability, and safety. The well-known file presentation is part of this method. And RAMS contains a lot of well-known parts, as for example, FMEA and other well-known methods. Two additional remarks to RAMS. If you need RAMS for the first time, you have a substantial initial effort to develop the model. But this model you can reuse in all the next projects. And the big advantage of RAMS is a sensitivity analysis of the severity for incidents, error, and loss. For example, a signaling light to loss is severe. 1 of 150 lightning lights loss is not severe. You will hear more from RAMS in the next presentation. Thank you for your attention. Have you questions? Bernhard.
So, Daniel, many thanks for your input. I have not received a lot of questions in the chat so far. So, we would now give the floor to the participants. Is any one of you interested in give a question to Daniel? Please raise your hand or open your microphone and ask the question, please.
Meantime, one remark in additional. This is a very small look on the complexity what I present you. If you go in detail, that will be more and more complex. Yeah.
Can I see any? Do you have any question?
Hi, yes. My name is Kaupo Sirk from Estonia, and I wanted to understand how many people were worked with these interfaces in this Gotthard tunnel project. Roughly an average per month.
In the there was how many was this? About 160 engineers who worked in the interface team.
I think I can additionally ask another question coming from Willy. He was asking what were the main difficulties in finding all the experts and interpreters?
The main difficulty finding the experts in this time when we began, 2005, it was not so difficult to find experts, and there was a lot of subcontractors with her own personnel who is building this. We began for the tender with 160 engineers and had 9 months. So you can see how cost intensive was only the tender. It was it was a little bit more than 10 million Swiss francs. And afterwards, there was about 600 to 800 participants on the railway technology part. And to find this was the task of the subcontractor, because the Transit Gotthard was working many years before.
Okay.
This. Yeah.
I hope this would answer the question. I received a question from Joachim Walitz, who was asking, how did you deal with unexpected surprises in your timeline planning?
Pardon?
How did you deal with unexpected surprises in your timeline planning?
Yeah, that was typical that the tunneling has retard. Tunneling has a lot of unexpected things, and they are late, over a year late to the planning. And we had a perfect planning team, so that we, how did it? We planned to overlay the two work. If tunneling has civil work has finished one section, we overtake this and began with the railway technology, so we can even gain 1 year. I will shortly look if I had a picture from our timeline planning. Just a moment, please. Oh, this is not on. This is on the other calculator from me. Sorry. Yeah.
So quite interesting answers. Another one, you were talking about around 160 people, 160 interface engineers. The question from Julian Heathcote is if those 160 interface engineers, did they continuously work only on these interfaces, or was this just part of their regular job?
This is just part of their regular job. So
Okay.
we had regular interface meetings in the planning phase once per week, afterwards once per month. And so this is a half a day preparation, half a day meeting. So this is not so exciting.
Yeah, I guess so. We got a question from Nick van der Hoer. He was asking if you have any experience in a combination of systems engineering principles with BIM. you know, this total new technology. Does an integration between these two exist already?
We had a subcontractor. He tried this, but our project management is strictly as the not BIMs strictly in the conventional line.
So he did not want to let BIM be part of all this systems engineering.
I have experience in BIM by Robert Bosch, and it's interesting.
Okay, but you have not used it really in this Gotthard-based tunnel project.
No, in the Gotthard-based tunnel project, we have not used BIM.
Do you think it would probably help in the future for this kind of projects?
It can be help, but I would say before use it in such a project, try it in a smaller project, so that you have experience in BIM before you try it in such a hyper complex project.
Okay. Thank you, Daniel. Is there any other questions so far? Antonio Di Paolo, you have a question? Yes, please.
Your microphone is mute.
Yeah, you have one. Yeah. Oh, you have no question. Okay, then it was only I only saw your hand raising. So if someone wants to get in contact, raise your hand or
Okay.
you can clap your hand, whatever. So if there is no question so far, then first I would like to thank Daniel for the time being. Probably at the final end of our meeting, we can have another question if something arises during probably the next speaker. So thank you, Daniel, once again.
Thank you very much. And
great job. And I will hand over to our next speaker, to our next expert. Our second speaker is Mr. Nino Cingolani. He has a master's degree in engineering and was responsible for investment planning and control at the Italian State Energy Group, as well as executive investment director of the Italian Railways Holding and head of strategy department of Trenitalia. It's a huge project you managed in Saudi Arabia as well as in Thailand and Egypt. So I think a wide span of knowledge on this topic, and he will talk about RAMs and life cycle costs as additional critical factors for long-term success. So Nino, thank you very much for joining us, and I give you the floor.
Thank you very much, Bernhard. I'll share the presentation if you allow me. Do you see the screen? Yes.
Yep.
Okay. Okay, my speech will be based on two main subjects, which can be considered sometimes ancillary, but in effect they are not. Having assessed what Daniel make understood to us about the importance of having a strong and comprehensive organization with process specialists and system integrator. Two aspects. So the first is related to the operator perspective. Basically, the operator's eye during the design phase, because the operator will undertake the operation and maintenance activities, and at the end of the day is responsible for targeting key performance indicators which are defined during the design phase. I'm referring, for example, to the layout of the tracks. I'm referring to, for example, the position of the depots, the position and the number of stations. So all these are, and many other radius curve and so on. And all these parameters, let me say, should be compliant with the timetable, because the operator will be responsible for that, will be responsible to target this kind of key performance indicators. The graph, the picture shows exactly this. We can see that going clockwise, we can see that the key operation parameters affect both the infrastructure design and the selection of the rolling stock, which has influence on the timetable, and that this must be compliance with the operation and maintenance activities to reach the targeting KPI. This is one aspect. The second aspect is, as already Daniel mentioned, is the life cycle cost approach. So the importance to have a methodology adopting technical and functional references. Then we will go in a bit more in detail about these technical and functional references, pursuing cost-effective solutions on a long term, specifically the life cycle of the assets, during the maintenance service and the operation and operation activities. Specifically, when we talk about life cycle cost approach, I want to show you a graph, maybe is very well known, just to give an idea about the, and having in mind the cost-effective solutions we were talking before. Having in mind this, we can see that the cost at a life cycle span sometimes are 2-3 times of the capital cost. So the OPEX, the operating expenditures, are much more heavy than the CAPEX. That's why it is important to have a vision on a life cycle cost, approach. And we have to say that RAM's methodology, RAM's disciplines cover well the two aspects that we are mentioning. Sorry, I don't know why. Okay. As Daniel was saying, RAMS is an engineering discipline that is looking at the quality of the rail services through a number of characteristics or parameters which are defined at an early stage of the design in order to make this compliant with the future services, rail services and transport. Finally, also RAM's management focus on the railway risk. This is another important part of the monitoring and control activity done by RAM's discipline, because we know that railways risk have a potential to cause injuries and/or fatalities in staff and passengers, environmental concern, damage to assets, properties, and so it is important to have this kind of discipline. Let's focus now on two main aspects. One, we were talking about the reliability, availability, maintainability, and safety characteristics. What are they? So here is a list, not comprehensive, is a checklist of RAM's key performance indicators. These are quantitative parameters that should be assessed, set up, and agreed between the designer, the operator, and possibly the suppliers of the systems and component of the railways. Here are described. We can see many kind of quantitative and qualitative parameters. For example, the mission profile, so the working schedule of the rolling stock once in operation, daily utilization, the duration of the life cycle, expected life of the asset, the warranty period, the calculation rules for service reliability and availability of the assets, but also the safety constraints of the hyper-complex railway project, the frequency of the diagnostic data flows in order to have a robust monitoring system of the assets, but also other kind of parameters related more to asset reliability and availability, such as the medium time before failure, the medium distance before failure, the medium time to repair, to fix the asset, and things like that. Also, as already mentioned by Daniel, the FMECA analysis and the presentation, for example, the default tree analysis. All these, this is just an example, but all these parameters should be well defined during the design phase. Sometime in a specific project, also simulation of the operating model is performed, for example, with the software OpenTrack, in order to check if this kind of technical and functional characteristics of the future operation and maintenance service is compliant with the design that is taking care. This is one aspect. The other important aspect is related to the controlling procedure, which is embedded inside RAMs to monitor and control the potential threats, such as faults, failure, and errors that affect the quality of the rail traffic service. So we once again, we see that our definition of RAMS parameter are focused on the future services of the rail to be defined at the beginning, and also the provision of controlling processes such as failure prevention and fault prediction. But this is because also RAMS is a structured approach based on international standard and following the Plan, Do, Check, Act approach, which is the base of the quality system. And moreover, the RAMS is coherent with the safety management system, rail safety management system. So all these methodologies are integrated to form a structured system for control the railway risks. And this is the graph that is showing exactly this. One part of my presentation will be devoted also to an example of application of RAMS parameters to the maintenance model, specifically a very innovative maintenance approach, which is the predictive maintenance. Now we will go in more detail to see how this maintenance that is called the maintenance engineering is a new approach based on RAMS, and so pursuing a cost-effective solution during the operation and maintenance activities has the following benefit. This methodology is a maintenance process that goes beyond corrective and beyond preventive. Beyond corrective because try to fix the failures before they happen. And the preventive because the maintenance is no more based on kilometers or based on time, but it is based on real health of the assets or component of assets, because the assets are strictly monitored time by time through diagnostic systems. One of the parameters of the RAMS is related to the frequency of the data of the diagnostic data, when they should be sent from the ground to the control room. This is exactly what we were saying. Identify anomalies and faults in real time because the state of health is monitored continuously with huge increase in asset availability. So one of the RAMS parameters, we see it. And third, also the maintenance cost reduction because no redundancy of components and breakage reduction. And also let me add the obsolescence management, because through this application we can also manage, and RAMS, we can also manage the obsolescence of the spare parts. All these maintenance, sorry if I run this, but we have to be short in our presentation, but I am available to reply to every question. Here is the architecture of this maintenance engineering based on predictive maintenance, where we can see that an organization must be implemented, made by diagnostic data coming from the sensor, which during the design phase should be exactly designed to give to send the data to servers. Then as a diagnostic data, also the CMMS, so the computerized maintenance management system, which contains all the historical data, and putting together the historical data of each single asset together with the information coming in real time from the tracks, from the catenary, from the rolling stock, etc. These data are conveyed into a big data system, and through the data analytics are screened and to produce and transformed in information that are sent to a dashboard where the maintenance operators can see, check, and react to according to the information that they see on the dashboard, and react and activate the work orders in order to fix the failures. This is a way producing huge savings in the maintenance process, and let me say this is a son of the RAMS applications. Because it is coherent with this philosophy. Finally, we can say that RAMS discipline is the core of the asset management agenda made by these 4 pillars: preserving through long-term vision in terms of life cycle cost approach, calibrating suppliers to operators, to designer standpoints. Number 2 is the optimization of the maintenance service model with RAMS parameters, balancing a key performance indicator and maintenance cost by using innovative technology. Number 3 is the human factor, so the establish a proper organization and empower the people to work in different way, because predictive maintenance force the people to work not in a traditional way, and this need training and coaching. And last, optimize warehouse spare parts by adapting purchase reorder strategy to face up obsolescence. For me, I finished my presentation, and thank you very much.
So, thank you, Nino, for your great input. I have received not really questions in the chat while you were presenting. So I would kindly ask now at the end of this presentation if anyone wants to give an input. I received the question now about to you, Nino, which performance indexes are most common?
Thank you, Imans. The most common performances are related to the compatibility of the timetable. For example, a proper headway of the line and the service. Another important parameters are related to the components of the rolling stock. So to have components which respond to some criteria of availability of the asset and maintainability, so cost. These are, in my experience, 2 important aspects. And this must be guaranteed by suppliers. Consider that many times these parameters are included in simulation models to check effectively if the system respond to our inputs.
Very good. I hope this could.
If I can addition costs from railway technology, Gotthard base tunnel, the project has cost of 2 billion Swiss francs. The operating costs for 100 years are a little bit more than 2 billion Swiss francs.
Okay. Good input. Does anyone have another question from the One question was again about the performance targets for greenfield project. So can you please advise how to set performance targets for the greenfield project?
Yes, I mentioned at the beginning of my speech that these kind of activities should be done together with suppliers, because of course we cannot require to the market challenging parameters that does not exist. And so this is an activity that suppliers should do together with the client and with the designer of the asset. It is not a difficult task. Also because nowadays there are experiences on this field, and there are also experts that work on this field to prepare checklist for different kind of components.
I would forward to you another question, which comes from Amy Milling, was asking about difficulties arise in major projects due to these RAMS aspects not being sufficiently addressed in the initial contracts. How can this be addressed in ongoing project without the contractor increasing the costs extensively?
Addressed in ongoing projects. Yeah, very good question. This is not for ongoing project, for brownfield, for brownfield project. The possibility to have RAMS parameters to be included bring for sure increase of cost, because sometimes the suppliers didn't provide the client with products compliant with RAMS expectations. Sometimes yes. So I think this should be a negotiation between parties.
Mm-hmm. And question from our president to you, Nino. Do you think that organizations are always open to spend money for RAMS analysis?
No, I don't think. Yeah, this is a challenging. This is a challenging task. Let me say in a friendly way, it's a fight. It's always a negotiation and a fight, because it's a kind of culture. It's a kind of culture that is not easy to be spread inside the company.
Yeah.
I'm happy that you agree with me.
Yeah. I think we have to extend these things and to bring it more into project as well as the systems engineering approach.
I fully agree with you, Bernhard. Yeah.
Yeah.
Yes, I agree. In Gotthard base tunnel, it was mandatory that we use. And
Okay.
the thing is, you have to show the advantage of this method.
Okay.
You will have a lot of win of cost if you are consequently using this method, because you prevent the costly faults.
Yeah. I received another question from a good colleague, also from mine. He was asking that the RAMS criteria is quite far developed in the signaling, in the field of signaling and vehicles, but not so developed for superstructure. So
That's
they are
true.
very scarce. So did you include many RAMS parameters already also for tracks and for superstructure projects?
Just once. Just one experience for infrastructure projects. Yeah.
And how was the feedback? Was it after the project has been finished? Was it said that this was a good aspect to have it in, or?
No, the project is still under construction, so I
Okay.
don't know. But we established RAMS parameters during the design phase. It is a project in Thailand.
Okay.
It's a high-speed project in Thailand.
So I think this topic of RAMs and also systems engineering becomes much more important also for the future. And it would be good to educate our engineers, our system engineers, after a long period of experience, to go into the field of systems engineering. Yeah.
I think so. And in Gotthard based tunnel, it was the same. Our track people came and told us which data should we take, and then we meet and we look which data is available for a period to change track and all these things. And from this and from the meantime between repair all these data, you can make a RAMS model.
Okay.
And perhaps it would be interesting that the union can help our members in these questions.
I fully agree. Yes.
You know that we have arranged for the last years many seminars on the so-called systems engineering, and I think we are still working quite hard on making it also available to engineers. So let's see how we can proceed on this topic. Yeah.
Yes, I support it.
So
Good suggestion. Yeah.
Like our certification for the European railway engineers. We could also provide something like this for the systems engineers, and I think this would give a better chance, especially in the big projects, to have better knowledge in. So, is there any other question from the chat group or from our participants? I think we had a quite big range, but of course, it was focused from the helicopter perspective on this kind of project. It would be, of course, very interesting to get sometimes a little bit more into detail. One question from a participant arised if it is possible to create a few templates on real applications of RAM analysis to superstructure. Is there any template we could provide or put on our website to give our European railway engineers a feeling how it could be done? The question was to Nino. I do not know if you're still here. Do you have some examples from certain projects, especially for the superstructure, where you have some templates or some pictures, some graphs or something like this, which deals with this topic? We can send or deliver it on our homepage.
Let me check. I'm not sure. Because what we did as a RAMS application in this infrastructure project, what was related to definition key performance indicators for the future maintenance model. So I have something. I will share with you. Let me check. But this was specifically for the maintenance of, because most of the infrastructure was on viaduct, and so we tried to define a way to monitor this kind of infrastructure, also because Thailand is affected by a ground which is not so stable because of water subsidence, I think. And so we applied this methodology to monitor the effect, the performance of this infrastructure. If I find something, I will share with the audience.
Perfect. You can also put it on the presentation at the end of the presentation, and everyone can have a look at it. Another question arises on, especially concerning this topic we have discussed right now, if there is especially an implementation for these reliability indexes. Do you have an idea how it can be implemented?
For rolling stock and signaling project is easier because there is, I think, now a very good literature about infrastructure. Maybe less.
Okay. So,
but we can, according to what Daniel was suggesting also, and you, why don't we launch a request to the European colleagues to share this kind of experience, because could be a success of this kind of event.
Absolutely. Is there any question which arises from the audience? Please feel free also to open your microphone and ask the question of yourself. So one question still arises on the chat from Agostino Di Paolo. He was asking, is it applicable run standard 5126 to infrastructures and signaling? Is it for both applicable? I think so.
I think it's applicable. Yeah.
So you only have to translate it also in the world of infrastructure. Signaling is actually infrastructure. It's part of infrastructure. Probably not so prominent in the area of superstructure and in civil engineering, more in the signaling. So if someone wants to ask a question on his own, we would like to give you the possibility, raise your hand, then we can open your microphone and camera, because we had to shut it down, that we do not have too many talks in the background. So if you want to ask another question personally, please raise your hand, and then we open your microphone. So it seems that everyone is happy with your presentation and your answers. I'm also very happy.
Thank you very much.
I thank you both for your presentation. We will of course put all the presentations on our website after this seminar, so everyone has the possibility to download it or to have once again a look at it, as well as the recorded file from this meeting of today. I would like also say thank you to all the participants for the first railway talks. I hope it was interesting for you. We plan this kind of railway talks in a periodical way, every 2 or 3 months, a total new topic. And I would like to hand over to Olaf again to say the final words or even to advertise our next talks coming up in a few weeks. Thank you.
Yeah, thank you very much for all the participation, for the presentations, for the moderating of the presentations. And I would only like to invite you. We will shortly put a call for papers on our website for other railway talks. Our next railway talk will be held on 28th of March. It will be presented by Madeline. She is also part of our president of board. And she will talk about young engineers in railway industry and innovation in railway industry. So you are invited to participate again. And of course, we would be glad if you send us other topics. Maybe you have presentations that you can give, or you know somebody who will do the presentation. Thank you very much for coming. I'm very happy that we have had more than 100 people participating today, and see you very soon. Thank you.
Thank you.
Thank you.
Bye-bye.
Thank you.
Bye-bye.
Thank you. Bye-bye.